Welcome Algebra 2. This video is on roots and rational exponents. The essential question is, what is the relation between roots and powers? Let's begin. So we're going to start with some vocabulary about the radical form here. And there's three main vocabulary words. You got your radical sign, which is that check mark thing you've seen before. That's the radical sign. Underneath that radical sign is what we call the radicand. And outside the top left corner of the radical sign is something we call the index. You might not have seen before. The index is the degree of the root. So usually we have a blank one. It's just like square root of 16 is 4. But that's actually equivalent to the second root of 16. So whenever you don't see an index in there, assume it's the second root or the square root. We're going to also see cases where it's the cubed root or the third root or the fourth root and maybe beyond that. So that's what that index means. The radicand, again, the term under the radical sign. So let's do some examples of roots. You know how to do square roots here. Square root of 121 is going to be 11 because 11 squared equals 121. And you know the square root of 16 is 4 because 4 squared equals 16. Well, cube roots have this kind of same idea here. The cubed root, the third root, also call that the third root, of 8 is going to be 2 because 2 to the third power, or 2 cubed, equals 8. 2 times 2 times 2. The cube root of 27 is going to be 3. Because 3 to the third power, 3 times 3 times 3 equals 27. Fourth roots. So the fourth root of 16 in this case is going to equal 2. Because 2 to the fourth power equals 16. 2 times 2 is 8. 4 times 2 is 8. Times another 2 is 16. And the fourth root of 81 is going to be 3. Because 3 to the fourth power equals 81. So hopefully you can see the pattern going on right there. Yeah. All right, so let's do some a little bit more difficult roots here. I want to find the real roots, if they actually exist. So for the first example, the square root of negative 196. Well, this case we'd have no real roots. So I'm going to say no real roots. Because you can't take the square root of a negative number. It's never going to have a real number. Now you might know the square root of 196, maybe know it or don't, but it's going to be 14. But square root of negative 196 is not real. Now we did do complex numbers, and you could say, if you want to be fancy and the most correct, you could say it's 14i would be the square root of negative 196. This next one here. Now it's the cube root of negative 8 thousandths right here. You might say, well, it's negative, there's no real roots. But when you have an odd root here, you actually do have a root, and the answer is negative 2/10. Because if you multiplied that out, negative 0.2 times a negative 0.2 times a negative 0.2. 3 negatives are going to give you a negative number, and 2 times 2 times 2 is 8, but because it's decimal places, it's going to be moved over a few spots, and you're going to get 8 thousandths, negative 8 thousandths, or we can say this another way, negative 2/10 cubed equals negative 8 thousandths. Ooh, it doesn't look nice. Okay, so when you have an odd root here, you can have a negative number. Okay, this one. This is the squared root of x to the 10th power. And just a reminder, when you have variables and you're taking the squared root here, you just divide by the index right here. So the square root of x to the 10th power would be x to the 5th power, half of the exponents. All right, let's talk about equivalent radicals and rational exponents here. So we're going to be converting between exponential form and radical form. So here's the formula for it up here. If you have something in the format a to the 1 over n power, you can write that in radical form. That n, the denominator of the exponent, is actually the index. And so you can go the nth root of that a. So for example here, I can write 16 to the 1/2 power as the second root of 16 because this 2 is going to the index and the 16 is going in the radicand. I can write this down here, 27 to the 1/3 power. That's going to be the cube root of 27. And if you want to simplify that, that goes down to 3. And this up here went down to 4. Y to the 1/3 power would be the cube root of y. And I want to convert this. This is in radical form. Let's convert to exponential form for fun. That's going to convert to 64 to the 1 over the index is 3, so 1/3 power. So that's how you convert. A little bit more about equivalence. Let's say if it wasn't just a 1 over some n, if it's some number m over some number n for the exponent right here. Well, it's going to convert just like this. That the m in the numerator of the exponent is just still going to be the power of the radicand. So for example, if you have 8 to the 2/3 power, that 3 still comes out for the index, but that 2, the squared part, still stays with the 8. So it's the cube root of 8 squared, which you could rewrite as the cube root 8 squared 64, and you could even convert that down to that's going to be 4. This next one here, 8 to the x to the 2/5 power, that 5 is the index out here of the root, and then you're going to write it as x. Since a numerator is 2, it's going to be x squared. This one, b to the 4/3 power, I can write as the cube root of b to the 4th power. And the next one, if I want to rewrite this into exponential form, I can write this as 2 to the 8, because that'll be on the numerator, and the denominator of the exponent will be this 3. So 2 to the 8/3 power. All right, let's do some examples. Pause the video. All right, so find all the real square roots of each number. So I'm going to take the square root of 10,000. Square root of 10,000 is going to be 100, because 100 times 100, or 100 squared, equals 10,000. The next one, square root of 1600ths, well, that's going to be 4/10, just like that. Careful with those decimals. Next one, pause the video. All right, simplify each expression. So we have the same basis here, and we're using some information from the last video. So I'm going to combine those. It's going to be 10 to the 1/2 plus 3/2 power. It's going to be 4/2 power. So 10 to the 4/2 power, I can reduce that exponent. So it's going to be 10 squared, and 10 squared is going to be 100. Now this next example, this will get a little tricky here. So they're not the same base, so we can't combine, but we can rewrite this 75. 75 is the same thing as 3 times 25. So I can rewrite that as 3 to the 1/2 power times 25 to the 1/2 power, and times this 3 to the 1/2 power. All right, so let's break this up into two parts. 3 to the 1/2 and 3 to the 1/2, that's going to equal 3 to the 2/2, right? And 25 to the 1/2 power, so we can rewrite that as a square root, right? I can rewrite that as the second root, or the square root of 25. 25 to 1/2 power converts. So 3 to the 2/2 power is going to be 3 to the 1 power times the square root of 25. Well, 3 to the 1 power is 3, and square root of 25 is just 5, so you have 3 times 5, which is 15. That's your answer. That's it.